For hundreds of thousands of years, a tool was a passive extension of human will. A piece of flint, shaped by a stone, sat inert until a human hand picked it up to strike. We initially approached search engines and navigation apps with this same mindset. We viewed them as high-tech hammers, digital utilities waiting in our pockets to be summoned when we needed an answer or a route. However, neuroscientists have found that these digital systems function differently than any tool in history. They provide a constant stream of stimuli that triggers physical changes in our brain's neural architecture. This creates a tension in our relationship with technology. We have to consider whether we are still the ones shaping the intelligence, or if the intelligence has begun to shape us. The Cath-Speth framework describes this as a closed feedback loop. Data flows from the human to the digital node, which processes that information and immediately pushes a modified response back to the human. We have moved into a phase where the algorithms we built to serve us now provide the specific sensory inputs that dictate our brain's physical adaptations. To truly understand the origin of this feedback loop, we must look at the way modern machine learning models are constructed. Rather than being programmed with strict mathematical rules, modern AI is trained on vast oceans of historical human data. It learns by identifying patterns within billions of our past decisions and communications. This training data contains the entirety of our recorded history, including the cognitive shortcuts, psychological flaws, and societal biases that define human behavior. As the network processes information, human prejudices become embedded in the machine's weights, forming its foundational logic. These weighted biases act as filters. When presented with neutral data, the machine warps it to fit skewed patterns learned during training. The resulting machine mind functions as a digital echo of our own flawed cognitive models. The second half of the loop begins during the deployment phase, when these biased predictive systems are placed in the hands of billions of users. As we interact with these systems, we engage in cognitive offloading, the psychological habit of outsourcing mental effort to an external device. There is a physical consequence to this reliance. When we stop using our internal circuits for navigation or memory, the neural pathways associated with those tasks physically weaken and dim. At the same time, algorithms maximize engagement by targeting emotional triggers and fracturing our attention spans. By conditioning us to respond to consistent dopamine cues, the system narrows the range of our typical behaviors. This narrowing of behavior makes us more predictable. When our responses are driven by limited emotional triggers rather than complex thought, the algorithm can forecast our next move with mathematical certainty. This creates a self-reinforcing cycle. Biased data trains the algorithm, it conditions human behavior, and the conditioned human produces narrower data feeding the next generation of algorithms. As this loop accelerates, the distinction between human intent and algorithmic output collapses. We are operating within a single, symbiotic system where the biological mind and the machine code are in constant, direct communication. Defending our brain plasticity in this environment requires active cognitive hygiene. These are the daily habits and regulatory standards needed to protect our mental independence from constant algorithmic conditioning. The way we designed our artificial intelligence today is effectively the way we are designing the future of the human mind. Ultimately, robust AI governance is not just a policy choice, but a necessary defense of independent human thought.